Okay, so I've shown you how to change things on the graph to go into the property editor. We'll see this. I'll show you this in just a second here. How to construct this, and how to put labels and things like that on. Now, there's something else we have to do, and that's to change the limits on things. Just remember, a lot of this stuff is really complicated. You're going to have to look up help on various things. So remember the function browser. You can type ECE102 in there, or here's fcontour, function contour, for example, it plots contours. F stands for function. Let me do one thing before I go very much further. There's a plot tab. Here's the home tab that you've been used to. Here's the plot tab. Drop it down, and here's all the easy plots. What's funny is MathWorks hasn't put the F plots on here that take the at parentheses variable name close parentheses. These are all the ones where you input strings. It's kind of funny how they work things. Anyway, here's all the different plots you can get. There's a zillion of them, as you can tell. We'll go down to here in just a minute. The easy plot, though, how to do limits, and I need to tell you how to do that. And when I hover over it, it tells you, oh wow, there's what we need to know. That you put in the function, and then you tell it the limits here, and it actually plots out to the limits. So let's see how that works. Easy plot. I'm going to do the sign again. And this time I'm going to put it in degrees. And just close it up. And let's see. And it doesn't make sense. Now, we can go in here into the figure and change the x limits. There. We can change the x limits to negative 180 to positive 180. This will not work. There we go. Because the data doesn't exist. When we executed this command, it didn't create the data from negative 180 to positive 180. It just created the data from negative 2 pi to positive 2 pi. So we've got to make the data exist. Here's how you do it. You do it here in the command, comma, bracket, minimum, negative 180, comma, positive 180. And did I put too many parentheses in? Yes, I did. Okay, hit it. Now this is starting to make a lot more sense now. Starting to make a lot more sense. Okay, let's go down to here. Let's see. Now we can do three-dimensional plots, which are these guys right here. Mesh, surface, contour. They all do. Here's a surf C. I'll try that one. Contour filled. It fills the contour. A contour, the surface and the easy contour are some pretty good ones to think about. So let's go easy surf. Okay. Easy surf or easy mesh. I'll show you the difference in just a second. Easy surf, and it doesn't have to do with surfers. X squared plus y squared. There we go. It produces a three-dimensional plot. I can't remember what MATLAB calls or MathWorks calls these. They are what they call them, MATLAB analytic plots. You give it an analytic function. Everything else takes data. You've got to create the data somehow. or get the data. Everything else takes the data. The easy routines and the F-plot routines take data. Excuse me, they're what are called analytic plots. Everything else takes data. Okay, get back to collapse it. Come on, there. So we have this now. Mesh. Let's show the difference between surf and mesh. Surface fills in the grids with colors. Mesh leaves the grids open. It just leaves the mesh lines like a net. Let's see, do we have an easy mesh C routine? There, we have a surf C. Yeah, we do have an easy mesh C and easy surf C. So let's do that. I'll do mesh C. What that does is it puts a contour plot underneath the 3D plot. There. These are contour lines. They show equal elevations. So equal elevations will be a circle in this function, x squared plus y squared. So the lowest part is here, and if you went this direction, you'd keep going up, 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 up. You'd be starting at the bottom and be climbing out. And these circles show equal elevations, like a topographic map, if you've ever done any hiking. I'm going to get rid of the property editor. Okay, so now you can also do, so remember this view right here, and I might just get into subplots right now so that you guys can, subplots are kind of useful. I'll show you that in a sec. Easy, what was the routine? Contour. They were sitting up here in the plot routines. There we go. So that's the contour plot. Remember previously we had the contour and the mesh together. Subplot. Now what this does is it divides up the plot window into, you tell it how many wide, how many deep, and then what position. So we're going to have 2 wide, 2 rows, or excuse me, 1 row, 2 columns, and I'm going to put the first plot in position 1. And then I go do the plot. And I wanted to contrast what this looks like, this plot, with, now I'm going to put the second one in position 2. I wanted to show you guys the difference between this and the contour. There we go. Contour. There we go. So we can see that this down here is, this is showing the projection. This is showing what a contour plot of this is, of this shape is. This is the contour plot alone, how the contour plot alone works. And now you can see them side by side. And this is the value of subplot. That's kind of a neat tool. Okay, I'm going to end this video here. And don't forget help, by the way. Before I end the video, let me just say help. You probably saw me use subplot and you're going, how did I do that? Okay, let's go help subplot. I'm going to make it bigger. What it does is it creates m rows by n, and then this is position P, where you want your next plot to go. So they give a few examples. Don't forget the help system. Go Google, go help. This is too much. I can't tell you everything. you got to dig into the help system. It's teaching you how to fish rather than giving you a fish. Dig into the help, dig into Google, dig into, use this help, use the function browser, go to the question mark. So use those resources. I'm going to end the video now. We're going to get back away from three-dimensional stuff. These are the easy routines in the three-dimensional. I'm going to go back to plotting data in 2 dimensions.